Variables are a major part of any programming language. I can't think of a single programming language I've ever used that didn't use variables in some form. And so let's just talk about some very basic aspects of variables. Now, if you've been around programming a while, you've probably heard all this, but I would suggest you watch anyway, because there could be some things about C++ that might shock you. First of all, let's talk about the best definition of a variable I've ever heard. It is a small piece of memory that you control. Now, you control how it's created, when it's created, you give it a name, and you decide what kind of data is stored in this variable. Now, variables, just because you create it, name it, and decide what to store there, are governed by certain rules in C++ that you will have to abide by. Now, these are going to affect how you name your variable, what characters you use, how it's set up, the structure of the name. Then exactly what kind of data can be stored in that variable, and here we're talking about data types, and we'll do a separate couple of movies on data types a little bit later on. And we also are under the governance of C++ as to where we can use this variable, or from what parts of the program can we access the data that's in this variable, and that is referred to as scope, and we will do a separate video on scope a little bit later on, so you can look forward to that. I know you're excited. Well, let's talk about when we're naming our variables, what's going to be involved here. Well, first of all, when we're creating a variable and we're creating a name for a variable, we can use capital or lowercase letters, A to Z, any alphabet character, but we can't put blank spaces in our variable because it confuses the compiler. It thinks the variable name ended and something else started, and it'll try to use it. Now, we can use numbers in our variable names, but we just can't begin the variable name with a number, all right? So we can't have variables like 7up using the number 7, but we can have, mark 376. That's a valid variable. And we can also use the underscore character. Now, you're going to find that most developers fall into one or two camps, those who hate underscores in a variable name and those who love them and seem to use them in every single variable whether they need them or not. And you'll just have to decide what camp you're in there. And then we need to think about, well, how many characters can I use to name a variable? Well, there's some extremes here. One extreme, in Visual C++ 2010, for example, you can use up to, that's not a misprint, 2,048 characters in a single variable name. Now, please don't do this. Don't write novels and call them variables, all right? There's a happy medium somewhere. Many of the C++ compilers out there will only support 31 characters. So if you're going to use this C++ code in different places, don't go past 31 characters. But look, if you can't, name a variable with something meaningful within 31 characters, then you probably talk too much too, and nobody wants to talk to you on the phone and all that kind of stuff. Okay, so kill the drama, kill the over detail here. Try to hold it to just a few characters. Now, avoid naming them too short. If all of your variables are named X, Y, Z, J, K, A, B, R, T, nobody knows what that means. You won't remember what it means. So try to be descriptive. Try to stay under 31 characters, and everybody's going to, well, not everybody's going to be happy, but more people will be happy, all right? Now, here's the thing to watch for. This will get you. Variables in C++ are case sensitive. This is a case sensitive language. So the variable weight with a capital W is not the same variable as weight with all lowercase letters. Be very careful with that. You will introduce some very interesting challenges and errors into your code if you're not aware of case sensitivity. Now, when we're talking about data types, when we create a variable, we declare it to have a certain data type, and this tells the compiler what kind of information I'm going to store in that variable. And that is going to affect the size of the data that's going to be stored in that variable. Because we can give it certain data types and tell it, look, we're just going to store numbers, up to about 127 here. Or we may tell it, we're going to store up to 2 billion in, number values here. And so the compiler will set aside more space for the computer to use for that particular variable. And just like we're packing stuff in our attic, we want to use boxes that fit what we're storing, and we don't want to take a giant refrigerator box and put just a little small shoebox in it. We want to make sure that we utilize our space. And so our data types simply tell the compiler how much memory should be utilized by the variable. And there's going to be some movies out here in the course called data types, and you can go watch those. So there's a lot going on with variables. These are just the basics. You'll see me create a lot of variables in the examples, and we'll talk about some odds and ends about variables as we go through those examples. But I just kind of wanted to give you a good, quick foundation here about variables in C++. Now let's talk about the topic of integer type modifiers. Now this sounds very complicated. It sounds like a really neat computer nerd type description. But an integer type modifier is simply a way to designate which form we want our variable to store data, because the bottom line is that some of the variables that we use in C++ can actually store the data in two forms, and we have a choice here. We can use a signed type data type, and that will store both positive and negative numbers, or we can elect to use an unsigned type, and that stores positive numbers only. Now, first of all, let's talk about which variable types we're talking about. We're talking about int or integer. We're talking about the short, which is a shorter integer, the long, which is a longer integer, and then the char that you'll hear it called sometimes, or the character data type. So anytime we're using these data types, just understand that this is kind of cooking in the background, okay? Now the default type modifier for your integer types is going to be signed. So for example, with the integer, I actually code int x equals 5. What I really told the compiler is I want to use a signed integer, and I'm going to go ahead and call it x, and I'm going to set it equal to 5. All right. Now to use an unsigned int or any kind of unsigned data type, I'm going to have to actually type the word unsigned out there. So the same thing there. If I'm going to create an unsigned integer of x and set it equal to 5, I'm going to have to actually use the unsigned word. Now, I know what you're thinking. What's the big deal? What's the difference here? Well, let's talk about it this way. The signed integer can store positive and negative numbers. So really what it does is it splits the total it can store right down the middle. You'll notice the negative one can go one more, and it stores from negative 2,147,483,648 to positive 2,147,483,647. All right, so we're just kind of splitting it right down the middle. Now an unsigned integer data type can store from 0 to 4,294,967,295. I know you appreciate me reading these numbers for you as if you couldn't read them yourself. But anyway, moving right along. Notice that if I'm trying to store large numbers that won't exceed this, I can use an unsigned integer and take care of that. But keep in mind with unsigned, I can't store negative numbers, all right? So this is going to be one of the choices that you get to make as a developer. Now there is something I just want to show you right here, something you might see out there, and you'll see sometimes that some developers, when they use unsigned, they'll create an unsigned variable called x. It's the data type long, and then when they set it equal to a value, they'll put 2, and they'll actually put ul for unsigned long out here, and this will actually help the compiler to make sure that it doesn't change it to a signed long. Well, that's kind of not a problem most of the time, but you will see that out there in code. So anytime you see letters out next to a number like that, it's probably a hint to the compiler that this is a signed or an unsigned or something like that. So anyway, just wanted to go over these integer type modifiers with you. You'll see the term out there a little bit, but most of the time you'll see it in the form of seeing the words signed or unsigned in front of your data types when you're creating variables. Constants are a type of variable that we can use in programming that gives us a very specific purpose with the variable, and I want to talk to you about it in this very short video here, but I wanted to make it separate so that you understand this, because we're going to build on this a little bit later on in the course. First of all, a constant is really a variable that is read only. Now, if you can't write to the variable, how do you ever give it its first value? Well, what happens is we're going to declare a constant just like we do any other kind of variable, and we're going to give it a value. And once our program is compiled, then we cannot go back and change the value of that constant variable. All right? The compiler is going to check for any statement that attempts to change that constant variable, and if it finds one, it's going to squawk at us, throw an error, and it's not going to compile the program. All right, now, why would we want to use a constant? Well, let's say that we have some aspect of our program that we want to remain solid. We want it to be unchangeable. We don't want to introduce any bugs, any unanticipated actions. And so we declare a variable as a constant. We set it equal to a value. This could be like an interest rate, a price per pound, anything like that. And we know that that number, that variable, is not going to change as the program runs. Now, to define a constant, it's very similar to defining a variable. You're going to define your variable just like you always would before, except you're going to put the word const in front of it. Now, here's a little extra something for those of you kind of adventurous nerds out there. Constants have been called by a lot of people kind of the one of the most confusing aspects of C++. I don't want to go into it right here, but constants can be used in a lot of different places, a lot of different ways, and they can really get quite confusing. So you might want to jump out to Google and just do a little Google thing on constants in C++, and we will probably touch on this a little bit later on during the course, but I don't want to throw too much at you right here. But anyway, just take it from now that a constant is a variable that once we declare it and bring it into being in our code, once this is compiled, that x is going to be equal to 45 for as long as our program runs, okay? And we cannot change it. If we try to write a line that's going to change x after it's been declared as a constant, it's going to squawk at us, throw it out, not compile the program, okay? So that's a constant. Now, also, let me say this right quick. A lot of times, developers have certain ways of naming these constants, and you'll see that the variables are in all caps if they're constants and that sort of thing. Some people start them with CON. Just kind of watch the environment you're coding in, go by whatever coding structure they're using, or lay out your own, but just make sure you stay consistent with it. Okay, so anyway, that's constants.